just yet, but we soon will. Okay, so always make sure you have this with you. Don't think that I just killed a bunch of trees for no reason. Okay. All right. Well, that was probably one of the biggest things for students. They wanted to have a paper copy, right? Not everything PDF online, because that way it's in front of you, right? So we started to talk about quadrilaterals, and we talked about the rectangle and the parallelogram, and some of the things that were very similar. And obviously there are some differences, right? Like the rectangle has 90s all around. Okay, and also when it comes to the diagonals, a rectangle has two different ones, right? They do bisect, but they're different. Okay, whereas the rectangle has diagonals that are the same, so they actually end up having four sections that are all the same length inside. Then we talked about the rhombus, and it's related to the square. And there's a lot of things that are similar. So all four sides are equal, right? Opposite angles are equal. So opposite means this way and this way, this way and this way. Diagonals bisect, which is the same as before. Two pairs of parallel sides. No news there. And I forgot to mention this. I looked up my notes. This is true for both of them. You know how they meet at a 90 here? These also meet at a 90. Make sure you add that, because that is the difference between a parallelogram and a rhombus, is the fact that they meet at a 90. Okay, so I will highlight that. So make sure you do the same. Okay. Sometimes it's good to talk about what is not happening. So why don't we go up here to the diagonals of these two and just say diagonals, watch this, are not perpendicular. Does that mean anything to you? Perpendicular is a fancy word for meeting at a 90, right? So diagonals are not perpendicular, do not meet at 90 degrees. That's very important to have, maybe, right? Because then you know it's like, oh, that's one of the biggest differences between the two groups is this. Okay. So if I ever try to trick you, which one of these is not true about a parallelogram, right? I would say two pairs of parallel sides, check. That's good. Two pairs that are equal, two side lengths that are equal, yeah, that's good. If I threw in diagonals meet at a 90, right, that's not true about parallelogram. So you need to be able to tell me that. All right. I think I got it all. They bisect. And we're going to practice sketching these and labeling. Okay, so we're done with that. And now we're going to talk trapezoids. So split that. If you are running, if it's tight already, maybe go to the next page. Like if you're running out of room because you were writing to, like, go for it. I left both pages blank for that reason. I will actually use some of the backside, so don't be scared. So trapezoids, and the trapezoid family, we are only going to study two of them. One looks like this. It's basically the base of a triangle. If you cut off the base of a triangle, you end up with this. Think about it that way. And so this is an isosceles trapezoid. Wait a minute, isn't isosceles a triangle thing? No, there are isosceles shapes. A pentagon, um, if you cut it, could also be isosceles. So isosceles trapezoid, and there's a right trapezoid. So let's draw that right underneath. And the only difference is that it looks like this, where one side is straight and the other side has a triangle. It's almost like a rectangle and a triangle combined, right? So this is a right trapezoid. So I always like to talk about what's true for both of them first. And in this case, this side is parallel to that side. So this has one pair of parallel sides, and so does this one. Okay, so how about we write that down? One pair of parallel sides. By the way, if you're working on your study sheet and you see these markings, you can actually conclude that. So you don't have to have these bullets written down if you just do a good job at labeling the diagram. Okay, so that's true. And I need to be careful here. The isosceles trapezoid, I'm going to use a different color, has these sides being the same. They measure the same. So we will do that. We'll make an arrow come out of that and just say one pair of congruent sides. That's specific just to the isosceles trapezoid. And the right trapezoid, there are no sides that are the same, by the way. Let me just bring that all the way up so you can see it. But this one has a 90 here and a 90 there. Okay. So for this one, we're going to arrow up here and just say one pair of right angles. And here, one more thing that's true about the isosceles trapezoid is that this angle here is just like the triangle. The angles that are across are the same. And so are the angles that are up top here. 1, 2, 1, 2. And you're not going to like me right now because I should have done that first. I'm going to insert that here between these two pairs of congruent angles. Can we make sure this is together, right? Isosceles trap only. this is true for all of them. Okay. Okay. And now, before we get to the kite, which is the last one, I'm going to get you to add something to every single one of these. This is true for all of them. Okay. So I will do this on the side, on the margins here. I'll tell you that whenever you look at a shape, these two angles always add up to 180. And this one is easy to tell, right? 90 and 90 is 180. But it's true for all of them. So you just do one of these for all of them. That's going to be very helpful later on as we work with them, knowing that they're always 180 if you add up the one at the base and the one at the top. Like that, they're always 180. It doesn't count this way, but this way, yes, always. So let's go up to the square and the rhombus. We do the same thing. 180. And we go to the this 180. So we did that with the rhombus and the square. Then we go to the rectangle and parallelogram. You do one of these, 180. And this one is 180 as well. And you'll see how I'm going to use that later on when I'm solving. I'm going to use that extensively to get me started to fill in information about a particular rectangle or parallelogram. We're good? So exciting, huh? Properties of, it's like it's a rectangle, I can tell, right? I don't need to know the properties. Height. And this is true about a kite. So basically, start with a triangle like this, right? So pretend this is the hat, and then we'll have a slightly longer triangle going down like that. It should be a little longer, otherwise it's a rhombus, right? If you don't do that, it will look like a rhombus, so you want to make it look like that. Okay. I want you to think of it this way. This is just me. This is not textbook. Two isosceles triangles put together. Okay, that's what I want you to think of when you think of a kite. Two isosceles put together. So, what does that mean? Well, it means that this triangle up here, this is an isosceles, so we know that those two sides are going to be the same. And we know that these two sides are going to be congruent as well. So, boom, boom, right? It has diagonals. It has a diagonal going across like this, right? And it has a diagonal going across. So diagonals are always going across from one corner to the other corner that's opposite to it. That's a diagonal. Okay? We know that they meet at a 90 here. No doubt about that. They're perpendicular. We also know that this diagonal here is bisected. Okay? And now it's getting a little bit crazy, so I'm not going to keep adding to it. So I'll just make another kite because we have the room. So draw another one under it. So we'll just say that these two angles are the same. This one is the same as that one. You could have added that to the top here, but I think it gets too crazy there. Right? So a kite, these are the only ones, right? Congruent. Okay, so I'm going to say one pair of congruent. You don't want to write congruent, right? So I'm going to just do this. Congruent angles. These two are not congruent. Okay, these two are not. But we can later on we'll figure that out. Okay, so let's write down some of the properties so you can read it up. Okay, we can say two pairs of congruent sides shorter diagonal is bisected. Diagonals are perpendicular. I.e. they meet at 90, right? Meet at 90. I think I said it all. Two pairs of sides that are congruent. So this is one pair, another pair. Got that. Shorter diagonal is bisected. Diagonals are perpendicular. And one pair of congruent angles, which are these two here. Okay. One more thing here. Just to remind you, remember, sum of interior angles is always 360 degrees. So if you add up all four angles, because guess what? They all have four sides, so that means that there will be four angles. That's another property here. And this is always true. So if you know 3, you can easily find the fourth one, right? So let me just check. Yeah. So let's practice. Sketch a parallelogram, comma, labeling two properties. So I want you to give me 3 different versions how you could answer this. So what are you talking about, Mr. Dirksen? 3 different, so do a one parallelogram and label 2 things that are true about it. Only 2. Move on and then do another parallelogram. Label 2 things that are true about it. Different things. They cannot be the 2 same things that you've already used. So give me 3 versions. Okay. So you can cheat now. You can go look it up, right? It's okay, but practice. And then I'll throw another one at you before we start doing more mathy questions, okay? Because this book doesn't do enough of this, but the test will have stuff like this on there. See if you can do that. And there's the third one. So give me 3 ways a student could answer this question. sketch a kite labeling two properties. 3 versions as well. So we're going to go kite number 1, kite number 2, kite number 3. So all you need to do is the markings that's supposed to be on there. Don't erase, okay? You keep yours. So this would be one property. Done. And I'm going to go with this angle, angle. So these are the same. And these are the same. 2 out of 2 there for that one. Okay. Let's say you were a different student now. It's like, well, this one measures the same as this. This one measures the same as that. That's one property. Okay. And then let's say you wanted to do the angles as well. No problem. 2 properties done, 2 out of 2. Okay. If you wanted to do this, you label the diagonals, then you say this one is the same as this one, and this one is the same as that one. One property. Okay. And let's say you wanted to talk about parallel lines. 2 properties done. Right. So many combinations you could use. You could have, yeah, there are more options. You could have done diagonals and the fact that the side, these 2 are the same, these 2 are the same, you name it. You just have to be careful if you're using these markings and then you're going to talk about the side lengths. You technically have to use, like if you have 1, 1, 2, 2, then you have to go 3, 3, and 4, 4. Like you have to be. I wouldn't do that because you might run. It might be too much, but it's up to you. And then the kite, you can say, hey, these 2 pairs of equal sides. Okay, good. And then that this angle is the same as that one. Done. 2 out of 2. Okay. The next one, let's say you want to talk about the diagonals, that this one cuts in half. And if you want to talk about the 90, right? Done. No more. No parallel lines here, guys. Kites does not have. That's the only one that doesn't. Okay. So then, what else can I talk about here? Is I can mention that these are the same. These are the same. And I could use the diagonals meeting at a 90. Right. So there it goes. That's what I'm asking you to do. And I could do this in several ways. Like somebody's looking at a chocolate bar. Tell me why that chocolate bar is a rectangle. Right? And you could be like, well, if I asked you for a rectangle, you could just say, well, it has 4 90-degree angles. You can say that. You can say that opposite angles, there's 2 pairs of opposite congruent angles. It has 2 pairs of parallel sides. I'm basically asking you to draw from your list of properties of that specific shape. So sometimes I'll ask you to do that in words. So you got to be able to write that in words. Okay. And basically just state your markings, right? If I ask you, hey, what was done here? Well, there's 2 pairs of congruent sides and 1 pair of congruent angles, opposite angles, right? Here, the shorter diagonal bisects and the diagonals meet at a 90, right? So just be able to rephrase it and actually write it down. Fair enough? So beef up your study sheets, okay, for this. And here's just a little diagram on page 192. I find this one is it's helpful, but sometimes students weren't quite sure. But it's basically telling you if you follow this line here, you have your parallelograms, and under parallelograms you have rectangle or rhombus, and they're also somewhat connected. So I thought, you know what, let's just leave it. But you basically have three main branches: parallelograms, kites, and trapezoids. And if you think about it, a square fits under the parallelogram definition because it has two pairs of parallel sides, and so that is all you need for a parallelogram, right? So it basically says what I already told you, just as a diagram. But I want to emphasize this here. When classifying, be as specific as possible. Okay, very important. Right? Make sure you have an arrow going to it, right? That when you go through your notes, because a shape may be a rhombus and it also may be a parallelogram, but I want you to be specific. What is this specifically? Narrow it down as much as possible. Okay, let's keep going. Let's do some. Again, there's not going to be a lot of heavy math. It's going to be a lot of basing your knowledge of the shapes and whatnot. So this is on page 193. Okay, find AC, angle A, and angle B, and also what type of quadrilateral. So this is like an A, B, C, D type of question, right? That's not a big deal. I go to my diagram and we look at this and we're like, okay, follow carefully my train of thought. If this is 60 and this is 60, right? What can I conclude about these two sides? 60, 60 means that these are congruent, right? They're the same. Maybe I'll use a pen here. Right? Because of this, maybe I'll add that here. Base angles are congruent, therefore isosceles. Okay. So I can transfer and say, hey, if this is 4, then this is 4. Okay, so filling in some information. And let's answer AC. So AC is 4 centimeters. That one was easy. All you needed to do is look at the properties, right, of the shape. And then angle A, what do we know about these two angles here? What do these two always add up to? I told you that. It's always 180, okay? So if this is 60, then this must be 120, right? It's not that hard to figure that out. So I'll just assume that that makes sense. I won't show any additional math there. This is always true, right? So always true. Okay. So like Mr. Dirksen told me that the quadrilaterals, these two angles are always equal to 180. So done. So A is done. Angle B, I will do it the same way, folks. This is 180 as well. So if they're stacked up on top of each other, it's always 180. So this must be 120 as well. Let's do a final check. 120 and 120 is 240, right? Plus 60 is 300. Plus 60 is 360. So the interior angles of a of any four-sided shape should always be 360 as well. Okay, so there we go. And I already named this, right? So I basically started with the classification, and then I filled in a bunch of information to really answer this, right? So I went to that, then I went to that, and then I went to that, right? So this is my first step that I took, and I filled in a bunch of information, and then I basically was able to answer the rest. So sometimes you kind of go in a different order because it's more beneficial, okay? Okay, so the next question is asking us to find Wx. So where's Wx? Let's find it. This is what they're asking us for, right? And angle XYZ. So let's go X, Y, and Z. So they're asking us, this is our angle that we're missing here, this whole thing. So what this is, it is a kite. How do we know that it's a kite? Well, the diagonals meet at a 90, right? And we're told that this side is the same as that side. So we have enough information to conclude that this is a kite. So we know that this side is going to be the same as this side. So Wx is therefore answered, right? Wx is going to be the same as xy, which is 2 centimeters. And then they're asking us for angle y. We can actually call that angle y, but I'm going to keep it xyz. Is going to be the same as the one across from it. Is this going to confuse you? I don't want to confuse you, but xwz is the other one, right? Like xwz is the one across from it. So it's 101. And what's the sum? This one, I don't like this question, but I think it's beneficial to maybe look at it. WXY, so WXY, it's this angle right here. And YZW, if you just follow it, YZW is this one right here. What is the sum? They're saying, what would those two add up to? That's what they're asking you, right? What would these two add up to? Well, the sum of all four angles is what? 360, right? Inside, it's a four-sided shape, so it's always 360. So if we know these two, right, we're going to go 360 minus 101 minus this one, which is also 101. Right, let's just subtract. So 360 minus 100 would be 260, 160, take away 2, that's 158 remaining. Therefore, angle WXY plus angle YZW, right, that sum must be 158. It's just a weird question, but if that makes your head spin a little bit, just for now, don't worry about it. All right, we're gonna skip a few pages here, and and you're gonna try see if you can do what I just did. Over on page 195. So I'm going to tell you which ones we're going to work on. Work on page 195, so that means all. And then we're going to skip a few because I'm going to add stuff later. Let's try 198 and 200. We're going to work on those pages, and it seems like a lot. It's not that much, okay?